Hey guys, Miss Thompson here again. We are going to be talking about star systems and galaxies as I move myself around the screen here. So let's get right into it, and then we're going to have a little musical snack for you maybe at the end if, life wants to cooperate with me. And by life, I mean my computer, not so much. So what we have here is we are going to be talking about star systems. Our sun is just singular, uno, no dos. It is chilling out by itself in our solar system. Let me just move out of the picture. Hey, there we go. So it is up here, well, not up here, I'm up here, but it is out there in our solar system, and it is the only star in our solar system. So when you look at the sky, you're like, Miss Thompson, I see no stars, you lost your mind. Yes, true story. Those are stars. Yes, you are correct, but they are not in our solar system. Some may be in our galaxy, some may be in other galaxies. There is only one star in our solar system, and that is the sun. When you have two or more stars that are together, that is what you're going to have. That's going to be called a star system. I'm going to work all fixed and ready to keep rolling here because I'm struggling. But a star system, it is typically called a binary star system because there are two. Bi means two. So when you take a look at this, like this picture over here, what this is also showing you is that one star in the binary star system is typically going to be brighter than the other one. And in fact, you may not be able to see the dim star at all. So how do scientists, aka astronomers, know that there are actually two stars there? So what happens is that the dimmer star, the gravity of the dimmer star will cause the brighter star to wobble. Not like wobble baby, wobble baby, wobble baby, whoa, but like just shake. So then it's going to know that there is two stars there actually, and they just can't see the other star because it's too dim. Excuse me. You also have what we call an eclipsing binary. We talked about eclipses last week, maybe 2 weeks ago. It's kind of a blur for me. But we have talked about eclipses. So we talked about the solar eclipse and the lunar eclipse. Solar eclipse is when the moon casts a shadow on the earth because it passes between the sun and the earth. And then a lunar eclipse is when the earth casts a shadow on the moon because the earth passes between the sun and the moon. So what you have here is that one star will either go away, become dimmer, um, or yeah, that's it. I don't know where I was going with that because there is another star that is passing in front of it. So that's what we call an eclipsing binary. So binary again means two. So you've got two stars in that system, and that's typically the case. But star systems are just two or more stars together. Then you have other planets out there. Kind of crazy to think. Let me just move myself over. I'm blocking part of the title. What row? But scientists have found about 300, well, more than 300 other planets out there, not in our solar system. We have eight planets in our solar system. But in other areas out there, remember the three criteria to be a planet: it has to be round, it has to revolve around a star, and then it has to have a clear orbit. So there are trillions of stars out there. So it's a good possibility that they're going to have planets out there as well. Scientists have found more than 300. Obviously, they have not explored all of space, so they can obviously find more. But they do use radio signals, remember super long wavelengths, in order to search for life on other planets. We have not found any yet, but it's kind of crazy to think that maybe there's another planet out there going through a pandemic. Their students are having to learn remotely. Kind of crazy. We may not be alone. Probably not. When you think about how small we really are in the grand scheme of things, probably most definitely life out there on other planets, which is really kind of weird to think about. But go ahead and munch on that. Let me try to not block this picture. Okay. So when we have a bunch of stars together, that is what we are going to have. That's going to be a star cluster. So like it says here, all the stars in the same cluster form from the same nebula around the same time. And continuing with our same story here, they're about the same distance away from Earth. So you have two different star clusters that we're going to talk about. The first one is an open cluster, which is this one over here that I'm kind of blocking. Open cluster is going to be characterized by things like it's loose, so it's not as tightly packed. You can see how they're kind of spread out. It's kind of disorganized. It kind of looks like a mess, honestly. Your room sometimes when you don't clean it up. But these are also going to contain the really big stars. These are going to have giants in them and supergiants. Our sun is not a really big star. Our sun is actually a little bitty medium star. So it's really tiny compared to other stars out there. So those are going to be found in these open clusters along with a bunch of gas and dust. Your globular cluster is kind of like the older stars. They're more rounded, they're more tightly packed. I think they look prettier, honestly. Um, it kind of looks like a little firework. Boom! But these are made up of mostly older stars, so there is not as much of that gas and dust going on here because you have the older stars, they've been around for a while, and you're going to have more of them in the globular cluster. You're going to have you're going to have millions of stars in the globular cluster as compared to the open cluster. That's going to be in the thousands. I'm not saying like you're only going to have like 20 stars in that, but it's not going to be as many typically as are in the globular cluster. Kind of fun word to say, globular. You just said it, didn't you? I know you guys. I know you guys too well. Then we are moving into galaxies. So we've gone from star system to a star cluster. Now we're going into a galaxy. We keep getting bigger, keeps just expanding. So what we have in a galaxy is just a ginormous group of stars. So you have the single stars, you have the star systems, you have the star clusters, you have gas, you have dust, and you have gravity, keeping these things together. And then in these galaxies, there are upwards of a trillion stars in some of the galaxies. The larger galaxies have upwards of a trillion stars. And then on top of that, you have billions of galaxies out there. So our tiny solar system is like an itty bitty part of one galaxy, which is an itty bitty part of the universe. And then we are just an itty bitty part of our solar system, the Earth is. It's amazing to think how small we are in the grand scheme of things. So let's take a look at these galaxies. The very first one here is called a spiral galaxy. And you kind of have that disk, kind of looks like a smooshed little, I don't know, ball, um, apple. I don't know what you're going for. Kind of looks like a flattened, smooshed something in the middle there. And then coming off of that is going to be a bunch of arms, they call them, the spiral arms. And then if you look here, we are actually part of a spiral galaxy. Our galaxy is called the Milky Way. But these arms are going to contain a lot of gas and dust, which is what stars form from. So we are right here, sun's location. So that's how, and that's not even, I mean, we're not that big. It looks like we're an entire arm there, but no, we have to remember one star on that arm. So we are extremely tiny, and this is just, again, one galaxy of billions out there. But we are here on a arm, and so there are many stars in the Milky Way galaxy. And that's typically when you look in the sky, that's what you're seeing. You're seeing the stars of our galaxy, not just of our solar system, because there's only one, the sun. You see that every day. But you are also seeing stars from our galaxy. It'd be awesome if this would change when I wanted it to. Just gonna wait. Tick tock. Come on, elliptical galaxies. I know you got it in you. There we go. Apparently it didn't like my first one, so we just sat there and looked like a fool for no reason. So elliptical galaxies, they kind of look like spiral galaxies, except you've taken off the arms. You have that flattened disc type thing in the middle of all these, but no arms. This is not going to have nearly as much gas and dust in it. This is kind of like the elderly stars as well. So since there's not a lot of gas and dust, you don't have very many stars forming anymore because that's how stars form. They form from the gas and the dust out there in space. And so if you don't have a lot of that, then you're not going to get the new stars. So, oh my goodness, dawning. That is an elliptical galaxy. So it's got a bunch of like old stars. So the spiral galaxy is going to be the newer stars. Elliptical galaxy is going to be the older stars, and then you have irregular galaxies, which is just what they sound like. They are kind of like you just take pasta and you throw it against the wall. It's got no rhyme or reason shape to it, so that's why it's called irregular, because there's no regular shape to it. These guys are typically smaller than the spiral galaxies and elliptical galaxies, and again, this is going to have a lot of gas and dust, and so it's going to have younger stars, typically brighter younger stars. And then finally, we have what we call a quasar, another fun word to say. This is a young active galaxy, which has a black hole at the middle of it. So you have all of this gas and dust and all this goodness spinning around this black hole, and then it heats up and it kind of glows. It's kind of funky looking. So go from a star, our sun, the only thing, the only star in the solar system. Then we have star systems, two or more stars. Typically, they're going to be binary, so that typically means they're going to be two. They go in partners. And then you move to star clusters. You have the open cluster, which is disorganized, not as many stars, loose, more gas and dust. And then you go to a globular, well, not two, but then you also have globular clusters, which are kind of the older stars. Um, and they're more tightly packed together. They contain more stars. Excuse me. Then you're going to go to galaxies. Spiral is what we have. You have the flattened shape in the middle with the arms off of it. Younger stars, lots of gas and dust on the arms. Elliptical is going to be the older ones, not as much gas and dust, and it's just a flattened, looks like a flattened football. Then you have irregular, which again, no rhyme or reason to the shape, and that's got a lot of young stars, young bright stars with gas and dust, and then the quasar. Black hole at the middle of it, so much heat and everything rotating around this black hole that it glows. Now, for your little special treat, which I promised you, let me see if I can get out of this thing kind of easy. This has not been being very nice to me at all. No idea where the song's even at right now, but a little lip singing joy for you. Here we go. Look at you. When I look at you. It's a quick one. My computer absolutely hates me. I say forgiveness. Um, I was gonna give you a little something, but computer sucks. So hope you all have a good week and go check out the video on the Big Bang Theory, which is coming up next. Gotta go make that. Hopefully I can stay awake for it. Just kidding. I will. Meh.